Hello everyone, this is from LG Institute of Engineering and Technology. I am going to take the video lecture series on chemistry. The subject code for chemistry is 311001. Till now, in this particular session of chemistry, we have started chapter number 8's introduction, in which we have studied about basics of analytical techniques, right? So we have studied that what is actually analysis, right? Analysis can be of two types. Number one, qualitative analysis, while number two, quantitative analysis. Qualitative analysis involves identification of the substance. When we deal with the quantitative analysis, then quantitative analysis means the type in which we will determine the amount of that particular substance. So we need to understand here that identification of any compound, whether it's amount or whether it's characterization, both of them are known as analysis. Okay, and analysis is the most important part of any chemical when it is produced in any chemical industry. Whether it's a food, whether it's any kind of agricultural seed, or whether it's a normal chemical also. Firstly and foremostly, it has to be analyzed through analytical technique or analytical method and even analytical instrument, and then only it will be marketed in the field. Otherwise, it will not be considered or it will not be taken under the protocol of government. Fine? That is the reason that analytical techniques are very important for each and every kind of industry, and it gives you applications in almost each and every branch. It is not like that it is applicable only and only to one branch, or it is only and only restricted to particular field, but it is actually applicable to each and every field which is present around us, from the industries to the restaurants to any kind of particular material, any lab, any research and development premises, or any kind of higher education institutes. This is very important for us. Okay, now let's move ahead and let's see the types. So we have seen that we have actually electroanalytical methods. We have observed that certain kind of or particular kind of, again, spectroscopic techniques are there, chromatographic techniques are there. We have seen that actually we got NMR spectroscopy is there, we have mass spectrometry. So different types of techniques are actually present, but from which we need to apply to which analyte. To understand this particular criteria, we have to go through each and every kind of technique in detail, right? So for that we have to understand that which technique actually works on which mechanism or on which principle, and where it actually finds its application or its advantages, right? So in our previous session we have started electroanalytical methods, right? It involves the application of electric field for the analysis or for chemical analysis. That kind of method is known as electrochemical method or electroanalytical method, right? So here let's begin with the first one, which is conductometry and its applications. We already have seen certain different techniques are involved, but the first one that we will take a look on here is conductometry and conductometry technique, or I should say conductometry. So what do you mean by conductometry or conductometer, right? The thing, the analytical instrument which is used here is conductometer, a conductometric method, right? So it is an electrochemical method of analysis concerned with electrical conductance through an electrolyte solution, or another definition which I am giving you here is It is defined as determination or measurement of the electrical conductance of an electrolyte solution by means of conductometer or conductivity meter. Fine. The instrument is known as conductometer or conductivity meter. The technique is known as conductometric technique or conductometry. Fine. The method is known as conductometric method. These are the words which are very important for you when you deal with any kind of analytical technique. Right? This is the meaning of all this. Again, I am saying the words. First is conductometric method. Second one is conductometric technique. Third is conductometer. Then we have conductivity meter. Then we have conductometry. Okay, it's a method. So it's conductometry. You should say it as conductometry. Clear? Now, let's see that how it works and what are the principles of it. So, electrical conductivity of an electrolyte solution depends upon 4 different aspects. Number 1, type of ions. It involves cations, anions, singly charged ions, doubly charged ions, or many more. Okay? Then it involves concentration of the ions. Then we have the temperature, which plays a very important role. And last but not the least, mobility of the ions. It involves mobility of the ions. Make sure here that types of ions, because the mobility, the charge that the ion carries, that determines actually the value of the conductance. Fine. Then concentration of the ions, in how many or in how much amount does it actually present. Because if it is in high amount, then the conductance value will be changed. Similar way, temperature. If temperature will be raised, conductance value will be raised, certainly. And if it is decreased, then it will be decreased. Similar way, mobility of the ions, it involves many other things. Again, if the ions are much more mobile, then the conductance value will be different. And if the ions are less mobile, then the conductance value will be different. So you need to understand it here properly, that how it can be actually done and why this factors plays a very, very important role when we deal with any kind of or when we deal with any kind of conductometric analysis. Okay. Now let's move ahead to the principle of conductimeter or conductivity metering. So based on the conductance of the electrical current through electrolyte solutions similar to metallic conductors, right? Like conductance, which is A's with which the current flows per unit area of conductor per unit potential applied, and is totally reciprocal to the resistance. So conductance is basically the ability of the particular element to pass the electricity through it. In simple manner, if I say, then it means that the ability of an ion to pass the electricity through it is known as conductance. Okay, and we will measure the conductance here. Now, let's talk about the instrumentation which is involved in conductivity meter. So the instrument used to measure the conductance is called conductometer or conductivity meter. It consists of various things. Let's begin with them. First one, current source. Second one, alternating current source. Third one, conductivity cells. Next we will have cell for reactions which are producing precipitates. And last but not least is electrodes. In general, these are the things either which works as the source of electricity or which works for the transfer of electricity from one side to another side. And last but not the least, the capturing unit, that means the detectors. The detectors give us that the amount of conductivity which is passed through it, that means much more, because detectors are the most important part as well as or as another parts. Okay. Now let's see the applications of conductometric titration here. So conductometric titration shows its application in the strong acid versus strong base titration. Here in the image, as you can see, we can titrate it using different kinds of indicators. We can use pH indicator, we can use a normal indicator also, right, which shows us the end point for our titration, which occurs between a strong acid versus strong base. So here we will have on one side in the graph, as you can see, conductance, and on the right hand side we will have volume of base added. Conductance unit is generally taken as mho. Ohm inverse is the unit of conductance, which is considered as mho, mho. Fine. So what we will do it here, we will take it here, we will titrate it, we add our base into our acid. One point will be there, which is known as equivalence point. At that particular point, when we reaches at that time, B, which reaches an equivalent point, it shows us the exact value, the conductance value is raised to exact neutralization point, right? It is the lowest point in the graph. The value of conductance is lowest when we observe the graph. Why? Because in the starting, as you all know that acid contains H plus ions, and base contain OH minus ions. Now when we have H plus ions in a higher amount, the conductance value will be high. So in starting it will be high, but as soon as we add base into it, it continuously decreases and came to one point where all the H plus ions are neutralized by OH minus ions, and at that particular point the value of conductance will be lowest. Okay, afterwards what will happen? Now we will add OH minus ions. So what will happen again? OH minus ions will have certain kind of conductivity into it. So what will happen? The graph again begins to raise and it moves again, right? But it is for strong base. Okay, so the lowest point at which we will get an idea or we will get the value of conductance is known as the base. That means it is known as the neutralization point, the equivalence point. Okay. Next we will see in our next session. Thank you